Good morning students, this is Pankaj Mishra, your physics teacher, here again with a new lecture on physics class. Students, in this video we are going to discuss the basic concepts of units and dimension. So, we'll start with the basic fundamental quantities, like we'll start with physical quantities. First, we'll discuss what are physical quantities, then we'll classify them in vectors and scalars. We'll study some of the examples of those quantities, and later on we'll move to fundamental units and derived unit. In this video we'll be covering all these portions, and after that we'll discuss the units and dimensions, that is dimensions of the physical quantity. So students, let's start with the video. So first of all we'll discuss what are physical quantities. So as the name suggests, physical quantities, that means the quantities which are measurable, that is, they are those quantities which can be measured. So we classify these physical quantities into two categories. Number one, we write scalar quantity. Scalar quantity, as the name suggests, this quantity will possess or will have only magnitude. The quantity which has only magnitude but no direction. And we write a physical quantity with its numeric value along with the given unit. Like suppose I write force 20 Newton. So this 20 is your magnitude. This is your magnitude. That is 20 Newton of force is being acted. And this n Newton is your unit. So physical quantities are basically defined with magnitude and their specified units. So we'll say scalar quantities are basically the quantity which will have only magnitude but no direction. For example, speed, distance, time, length, work, etc. Since they will always possess magnitude but they will not have any direction. In some cases, most of the students get confused in case of work. Since work is a scalar quantity, but most of the students say, sir, work is equal to force into displacement, and force and displacement are both scalar vector quantity. So how can it be a scalar? So you should know one method that you will study in class 11th maths. We have to study dot product and cross product. So from that you can define, since force and displacement are vector, but dot product of any of the two vector quantity will give you a result, a scalar term. So from this you can say that work is scalar. ये क्वेश्चन आप लोगों को कई लोग पूछते हैं और बहुत इंपॉर्टेंट क्वेश्चन है ये. वर्क के ऊपर कभी भी वेक्टर का साइन नोटेशन नहीं होता है, सिंस इट्स अ डॉट प्रोडक्ट ऑफ टू वेक्टर क्वांटिटीज. सो दिस वाज अबाउट स्केलर क्वांटिटी. नाउ वी विल मूव टू द वेक्टर पार्ट. वेक्टर क्वांटिटी is just opposite to the scalar one. Since we can say in this case it will possess only magnitude, that is we emphasis on magnitude only, but in this case it will have magnitude and direction both. Magnitude and direction both. That means, for example, we'll write the example, then we'll study ki how can we say that. Like force, like velocity, like acceleration. So in all these cases you can see, suppose I am having this chalk in my hand and what I am doing, I am just pushing it. So what will happen, this will roll on my palm. So it is just rolling because of the force is being applied by me. So you can see that I am applying a force, that means some magnitude of force will be applied on this chalk, but it's moving, so it is moving in some particular direction. So this shows that it's a vector quantity. A book lying on a table is one of the example of vector quantity, since the book will apply force on the table and in return the table will also apply force on the book, and that force will be the normal direction. So in both the cases you can see that force is being applied in some particular direction with some magnitude. So this shows that force is a vector quantity and it will have a vector notation. So this was the basic concept of scalar and vector. So I hope you will understand all these terms. Now we will discuss units, as our first topic is units. So in this part we will study fundamental units and derived units. We will classify them in fundamental and derived unit. So in this fundamental unit we'll start with mass. There are 7 fundamental units and they are universally accepted. That is, all over the part it's same. That is, for mass we use kg, for time we use second, for length we use meter, for current we use ampere, for amount of substance we use mole, for luminous intensity we use candela, and what is left? Temperature. For temperature we use Kelvin. These all these all units are being termed in the name of some famous personality. Like for temperature we use Kelvin, but students get confused in between degree Celsius and Fahrenheit. There are some other units of temperature, but the unit which is universally accepted is Kelvin only. So fundamental units are those units which are universally accepted and they are not need to be derived. They are already universally accepted. But derived unit, suppose I say force ka formula is m into A. So what I am doing here, I am deriving this force from by using this fundamental quantity. Like acceleration is not a fundamental unit, this is also not a fundamental unit, but I am using this mass in order to derive this formula. So we can say that derived units are those units which can be derived from the fundamental part. Okay, so we can write force in terms of mass and acceleration. So student, that's all for today. I am finishing my lecture here only, and I hope you will like this video and you will try to understand the basic concept. So in the next part we'll continue with units and dimension. We'll study some of the dimension of the physical quantity. Thank you so much. Stay home, stay safe. Bye.